Hi everyone, welcome to my channel, and today we'll be going over analysis of variance. This is also called a one-way ANOVA test, and let me introduce the question that this may be applicable for. So let's pretend we're looking at movie theater attendance, and we're looking at weekly admission in millions of people attending movie theaters over 3 different time periods. Given an alpha value of 0.10, is there a difference in the means for the weekly attendance for these time periods? Use the p-value method with the graphing calculator. So I'll show you how to approach this question using Excel. The first thing is, how do we know this is a one-way ANOVA test? One indicator is that we're looking at more than one or two variables, and that way you know that you can't just do a t-test or a two-sample t-test or just a regular t-test. And the other indicator is that we're looking at a difference in the means for a weekly attendance. And that's a clear giveaway that we're looking for a one-way ANOVA test. So the first thing I'll do if I am given this data is I might want to try and visualize it. And one way I would like to try and visualize this is using a box plot. So I would go to Insert, I would go to the Graph section, I would go under Histogram, and I would click Box and Whisker. But first, let me highlight the data. So I'm going to highlight the data, then I'm going to click Box and Whisker. So moving this a little bit. Why did I do this? This is one way you can look at the variances really easily and the means really easily. So one thing I notice here is the means are the little x's in the graphs, and they do look pretty similar. Like they look around the same value, like around 25 or so. And so that might give me an indicator that there is no difference in the means. But we have to do our one-way ANOVA test to prove that. And so, again, I'll just label this movie theater attendance because it's a good habit to label your graphs. And then let's go into analyzing the data. So in order to analyze the data, I'm going to go to Data, I'm going to go to Data Analysis, and I'm going to scroll up to ANOVA single factor. And one way you know this is a single factor is because you can assume that all variables are normally distributed, the samples are independent, the population variances are equal, and the samples are simple random samples, one from each of the populations. So I'm going to click OK. I'm going to click my range of data, and then I'm going to click OK. And it was important to note there that it does say sort by columns or rows. And because my data is sorted by columns, make sure you click columns. And so my analysis comes back. I see the counts are 7, which makes sense given my data. I see the variances are quite different, which makes sense given the box plot and whisker. And I see the averages are somewhat similar, which makes sense given the box and whisker. So it's a good double check to have that. And the other thing to look for is we're looking for our p-value to determine whether there's a difference in the means. And so one thing to note is we're looking between groups, and our p-value is 0.4899. So let's go back to our data, and we'll note that the p-value is 0.4899. And before I progress any further, let's go over our null hypothesis and our alternate hypothesis. So our null hypothesis is that mu1 equals mu2 equals mu3, which basically means there's no difference in means. The mean of 1950 to 1974 is the same as the mean of 1975 to 1990, which is the same as the mean of 1991 to 2000. Our alternate hypothesis is that one of the means is different. Only one of these means has to be different in order for the alternate hypothesis to be true. And so given that our alpha is 0.10 and our p-value is 0.4899, what does that mean? It means because our p-value is greater than our alpha, we cannot reject the null hypothesis, which means there is not enough evidence to support the claim that one of the means is different, or that there is a difference in the means for the weekly attendance for these time periods. So let me just repeat, because 0.48999 is greater than 0.10, we cannot reject the null hypothesis. Great. Feel free to leave any questions in the comments. Don't forget to like and subscribe, and I'll see you in the next one. Thanks.